Dear student, welcome to my channel. This is the 9th video on C programming, and in this video we are going in detail for and while exercises. Now let us start. Write a program to print sum of even numbers and sum of odd numbers from first 10 natural numbers. So I equal to 1, sum equal to sum of even numbers 0 and sum of odd numbers 0. These values are initialized to 0. Now we want to iterate the loop from first 10 natural numbers. So we will start with I equal to 1 while I is less than or equal to 10. This is our final condition. Then it will iterate from 1 to 10, and when I becomes 11 it will come out of the loop. Now here we require to check if this number is even number, that is I mod 2, that is this is a condition for even number. If it is equal to 0, then we require to add sum of even is equal to sum of even plus I. So whatever the value of I gets added to the sum of even number. So that's why we make sum of even equal to 0. If that number is not even, then that number is odd, then we are making sum of odd is equal to sum of odd plus I. And this I plus plus is not under the if or else, it is a different statement. So if condition satisfied, this statement will execute. If condition is not satisfied, this statement will execute, and I plus plus will increment for every case. In this way it will iterate the loop for 10 times. When I become 11, it will come out of the loop because 11 is less than or equal to 10, condition not satisfied. When it come out of the loop, we have print the value of sum of even and sum of odd. So see, when this code is entered, this is the output. Now if we want to write down the iterate the reverse loop, that can be also possible. So for that, I equal to 10, that is we are making from 10 to 1, and while I is greater than or equal to 1. So that's why when we do increment at that time, this is the less than condition and always increment is there. When we want to decrement, always greater than sign is there. I equal to 10, I is greater than or equal to 1, and the same condition that I mod 2 equal to 0, then even update, otherwise odd update, and I minus 1. Now here we require to make decrement of I because greater than sign is there, and we are moving from 10 to 1. After that, print sum of even number and sum of odd numbers. So see, this is 1 to 10, these are the odd numbers. So odd number sum is 25 and even number sum is 30. If we want to write down the same program using the for loop, that can be also easy, but even in for loop the programming is easy because most of the value we can write down in that condition. For I equal to 1, this is initialization condition, sum of odd numbers equal to 0, sum of even numbers equal to 0. So this initialization takes place. After that, semicolon is there, and after that semicolon, final condition, that is I is less than or equal to 10 and either increment or decrement. So here it is less than, so increment I plus plus. If I mod 2 equal to 0, even update, otherwise odd update, and the I plus plus increment is automatically done after the execution of this statement. And once the loop ends, it will print the sum of odd numbers and sum of even numbers. If we want to do the iterate the loop from 10 to 1, that can be possible. Only change require I equal to 10. This initialization will be keep as it is while I is greater than or equal to 1 and I minus minus. So this will change takes place. So here it will goes from 1 to 10, and here it will goes from 10 to 1. Now I want to write down the program to input n and sum of multiple of 3, multiple of 5, and both multiple of 3 and 5. Now here we require to start with, for example, not we have to accept only single input number, but we have to start from 1 up to that number. So I equal to 1, sum of multiple of 3, multiple of 5, and multiple of 3 and 5. So when the number is multiple of 3, it is a fizz. When it is multiple of 5, it is buzz, and when it is multiple of 3, 5, it is fizz buzz program. So that's why I have given the variable sum of fizz, sum of buzz, and sum of fizz buzz. So they initialize to 0. Now enter the number n, and that number is accepted. From number 1 to n, we have to decide how many numbers are fizz buzz or fizz buzz. So here, while I is greater than or equal to while I is less than or equal to n, if I mod 3 equal to 0, that is that particular I has divided by 3, but at the same time it is not divided by 5, so that number is fizz, that is multiple of 3. So sum of f is equal to sum of f plus I mod 5 equal to 0, that is that particular number if it is divided by 5 but it is not divided by 3, at that time is buzz, and when it is divided by 3 as well as 5, it is what? Fizz buzz. So we don't require the other number, so only condition is taken when that number is divided by 3 but not 5, that number is a fizz. When that number is divided by 5 but not 3, it is buzz, and when it is divided by 3 as well as 5, it is fizz buzz. So this condition is nothing but sum fizz buzz, and this is if, else if and else if, and finally this I plus plus is increment for everything. So once either it will goes this if, else, or this else, if, and after that why I have not put an else condition only, because in else it will take other condition, but we have to take all these 3 specific condition. That's why the last is also connected with else if, and this is I plus plus, and it will iterate the loop. So it will take the number from 1 to whatever the specified value by the user n. Now if we want to write down the reverse, yes, we can write down the reverse also, that is move from n to 1 in this direction. So here we initialize I to n while I is greater than or equal to 1, and here I minus minus come. The program remains same, only instead of 1 to n it will take from n to 1. So what are the changes? That you initialize the number to the n, there should be greater than that is I greater than or equal to 1, and there should be decrement, otherwise program remains same. Same program we can do with the for loop also. See, with for loop the coding becomes very easy. I equal to 1, sum of fizz, sum of biz, sum of fizz buzz equal to all initialized to 0, I is less than or equal to n, I plus plus. Only we require to check down the condition, and if it will go to either one of the condition, so, and if not possible it will skip, because some numbers are not under the category of fizz buzz or fizz buzz, so it will skip that because the condition is not matched. That's why all specific conditions are given. Now again after this it will increment the I plus plus, take the next number, check whether this will satisfy the condition or not. So this is the second video. So in first video I have explained the loop in a very basic level, so that's why I am not explaining here again. If we want to do the reverse, yes, I equal to n, I is greater or equal to n, I minus 1s. So in this way also we can write down the for loop. Now next program, to convert a decimal number to binary. Now here, as we are not taking any advanced concept like array, so that's why we will compromise on answer. So it will print in a reverse order. For example, if decimal number 12 is there, then the binary number is 1100. So here actually it should print 110, but we are printing the answer in reverse direction, that is 0011. But once we use the array concept, we can immediately print this reverse result, that is 0011 to 1100. But as we have not introduced array yet, so we are printing a reverse answer, but the procedure remains same. Even we are using the array, only for the printing we make the reverse. Now integer decimal are, enter decimal number, resultant binary number is. Now here this is nothing but we are using the mod operator and the quotient operator. Now decimal is 12, so we first divide that number by 2 and we check the remainder. When we divide the 12 number by 2, at that time remainder is 0. So when remainder is 0, at that time that is printed. See, r is equal to decimal mod of 2, and we are printing that r value. But now next time we don't want 12 number, we want the reduction. So that reduction is nothing but the quotient. So two ways are there. So either you can use variable, or either you can directly decrement the number. Therefore decimal is equal to decimal by 2. Now decimal is, initially it is 12, 12 divided by 2 is what? 6. So decimal is equal to decimal by 2, so 12 divided by 2 is 6. So now the decimal is decremented. So here there is no specific decrement increment like plus plus 1 or plus plus 2, but whatever the it is divided by 2, it will take that answer. Now in the next, this will continue until our decimal is not equal to 0. Now our decimal is 6. Again we take the mod operator, decimal mod of 2. when we divide the 6 by 2, at that time again remainder is 0, so we will print that answer, that is 0. This 0 will printed. And now again we decrement the decimal by 2. 6 by 2 quotient is 3, so decimal from 6 it becomes 3. Next time we will take 3. When we divide the 3 by 2, at that time remainder is 1. When we will print screen on the screen, again we reduce the decimal by quotient value, that is 3 by 2. So when we divide 3 by 2, quotient is 1. Then number becomes 1. 1 divided by 2, the quotient is 0 but remainder is 1, so remainder 1 gets printed here. And 1 by 2, the divide quotient is 0, so quotient decimal number, that is our number becomes 0. So initial number is our 12, then it becomes 6, then it becomes 3, then it becomes 1. So after that it will becomes a 0. So we want to continue this procedure until our number is not equal to 0. But when our number becomes 0, we stop here. So after this 4 iteration, the decimal number becomes 0, and after that we will stop the loop. And meanwhile it will print all the values of remainder, that is 0, 0, 1, 1. Only it is printing the answer in a reverse way. Now if we want to do the program that decimal number to octal, what will be the change? Only instead of 2 we require to divide by 8. Now see, I will first explain. If instead of while, if we want to do the program using the for loop, that can be also possible. Now for, see, initialization is not required because here our number is decimal number we have accepted, so there is no need of initialization. What is our final condition? Decimal should not be a decimal, while decimal is not equal to 0. Decimal is not equal to 0, we will continue. And how we reduce the decimal, that is decimal is equal to decimal by 2. And here we are calculating the remainder and we are printing the remainder. So in this way, as we have taken the decimal, so there is no need of initialization, so therefore this is skip, so it is represented by only semicolon. So initial part before the semicolon is empty, that is nothing but there is no need of initialization. This is final condition, that is decimal not equal to 0, that is do the processing unless decimal is not equal to 0 and reduce the decimal by 2. So in this way we can write down the same program with the while as well as with the for. Only small changes are there, but once you do the practice, you will come to know which loop will be better for a particular program. Now same program, that is instead of binary we want to convert to the octal, so at that time we require to divide by only 8 instead of 2. So see, decimal resultant octal number, while decimal is not equal to 0, we take a remainder, we will print that remainder. Even we can write down this line and this line, that does not make any difference. And here we reduce the decimal by 8. See, decimal is 100, we divide 100 by 8, quotient is 12. So next time our number is not 100 but remain 12, and whatever the remainder we are printing, so remainder is 4. That is when we divide 100 by 8, at that time remainder is 4. Then we divide 12 by 8, remainder is 4, the quotient becomes 1. So initial number is 100, then 12, then it becomes 1. 1 divided 8, quotient is here the number is 1, it is by mistake 1. Then it is 0, and when 0, program stops, and meanwhile it print all the values. Only answer should be 144, but now here it is printing in a reverse. Now if we want to convert this program into the for loop, again it is very easy, that is for initial condition no present, because we have already taken the number, final condition not equal to 0 and decimal equal to decimal by 8. So in this way we decrement the number. In the for loop we are just calculating the remainder and we are printing that remainder. Now here we can see that how we can effectively use the switch and case for the decimal to hexadecimal. So in previous two programs we see the decimal to binary, decimal to octal. Now we will see decimal to hexadecimal. So for hexadecimal we require to divide by 16. So when we write down the program, at that time when we divide any number by 16, then how many remainders can be possible? Up to 0 to 15 remainders can be possible. So 0 to 9 we can print as it is, but when in hexadecimal number system, when 10 is there we are printing A, when 11 is there we are printing B. So in this way we are going from A to F, and f is nothing but 15. So here we can use effectively switch case. Now see, we are accepting the decimal number, then resultant hexadecimal, as I have copied the program, so that's why some minor mistakes are there. But when you write down this program, it is very easy to rectify that mistakes also. While decimal is not equal to 0, we divide by 16, then we reduce the number by 16. So when decimal comes, it's the values of the value of the remainder is between 0 to 15. So what we do, we use effectively switch case, switch R. Now whatever the remainder value is, go to the switch R, because it will always take as a constant value. Now here 0 to 15 values can be possible, but when values are from 0 to 9, we just want to print that plain R, and break should be there. So case 0, case 1, case 2 we can write down on separate line also. Because of space issue, I have written in a single line case 0 colon case 1 colon case 2 colon up to case 9. We have to print the value of R and break. For case 10, print a break. For case 11, break. In this way we can print from A to F, and this is nothing but the end of switch statement. So in this way we can write down the program. Now if we want to convert this program using the for loop, then only change is there is no need to take the initialization, because we have already accept the decimal. While decimal is not equal to 0, decimal is equal to decibel by 16. So only this statement will change, otherwise the program remains same. Now next program is write a program to print a letter from A to Z. In my previous video I have taken all these programs in detail, that is of ASCII value. Now you know the ASCII value of capital A is 65, and either we can write down 90 or we can write down 65 plus 25, because 26 characters are there. So if that's a capital A is start with 65, so we are including this, so including this plus 25 next characters are there, so total value is 90. So either you can write down 65 plus 25 or directly 90. So our loop starts with I equal to 65 and it will goes to the 90, that is the loop will start from 65, it will increment 111 and it will goes to 90. So while I is less than, see, increment is there, therefore always less than sign is there, and this subscript should be on the left hand side. So while I is less than or equal to 90, we are printing the value and the character. So when we use percentage %d, it will print the value, and when we use a percentage %d, it will print the character. So I have taken the screenshot, and you can see that it is printing the value of value as well as it is printing that character. So value of I 85, and 85 character is capital U, and once this loop ends, it will come out of the loop. When the value of I is 91, it will come out of the loop, because up to I is less than or equal to 90, this will satisfy. But when I becomes 91, it will come out the loop, because 91 is not less than 90. Similarly for loop, here directly we can write down initialization, final and increment, and there is only one statement, so there is no need to give opening and closing parenthesis. Here two statements are there, that's why we have given opening and closing parenthesis. Now next program is to accept a starting year and ending year and determine all the leap years between them. So start year accepted, end year accepted. Now we require to write down the while loop. So while I have taken I is equal to start. Even you can directly do with the start, there is no issue, but as for initial I have make this variable I, that's why I have taken, but you can directly start with the start also. I equal to start, and while I is less than or equal to end. So this is our initialization condition, this is our final condition, this is our increment. Now this is the condition for leap year, that if that year is divided by 400, that is remainder is 0, or if that year divided by 0 but divided by 4, but at the same time it should not be divided by 100. So this is the condition for the leap year, that is that year should be divided by 400, or if it is divided by 4, it should not be divided by 100. So this is the condition for leap year. So this condition is taken. If this condition is true, it will print that I, then next I plus plus takes place. and here I plus plus will do for every iteration, because if condition satisfy then only it will print the I value or year value, that is leap year value, and I plus plus takes place. If we want to do the same program for loop, then I equal to start, I is less than end, I plus plus. So this is the start, initialization condition, final condition, and increment. Now see, less than or equal to, increment is there, this is a condition, and there, because increment takes place directly here. Write a program to find the find the number of and the sum of all integers greater than 100 and less than 200 that are divisible by 8. So we make 101 because number should be greater than 100, so we should start with 100 and it should be less than 200. So while I is less than 200, so we require to find out the how many numbers are divisible by 8, and we want to sum that numbers also. So while I is initial condition, this is final condition. If that particular number come, if it is divided by 8, because when divided by 8 at that time only remainder is equal to 0. When it is divided by 8, we are printing that number, we are incrementing count, so initially count is 0. So if that number is divisible by 8, our count gets incremented, and we want sum of that numbers also. So sum is also initialized to 0, and sum is equal to sum plus I, that number gets added to the sum variable. And after this, when this condition is satisfied, at that time we want to execute 3 statements. So opening and closing bracket is there. So if that number is divided by 8, then only this will execute, otherwise it will not execute. And after that it will take the I plus plus for every number, because either this may execute or may not execute, but it will goes, if condition execute it will goes to 3 lines, otherwise it will directly comes to this line, I plus plus takes place. If we want to convert the same program into the for loop, it is very easy. Only what we require to do, for I equal to 101, I is less than 200, I plus plus, and even we can initialize count and sum in the initialization also. And after this loop we are printed the value of count sum. This is nothing but the very nominal. You can easily do the program for this. This is just printing statement. See, I equal to 101, we can initialize the variable here also, we can initialize here also, but it is better practice to initialize the variable in the for loop. I is less than 200, I plus plus, if condition satisfy, we are doing this, that's it, because I plus plus will take automatically takes place here after the execution, or after this particular condition may satisfy or may not satisfy, it will take I plus plus after that. Next program is, we require to accept the number of input terms and print the following series up to n. Now for example, see, n is equal to 5, then we require to accept 3, 6, 9, 12, 15. You can observe that all the terms are multiple of 3, that is n is 5, that is n is 1, 2, 3, 4, 5, and we require to multiply all that terms by 3. So it becomes 3, it becomes 6, it becomes 9, 12 and 15, that can we easily obtain. After that, what we require to see, alternate sign is plus minus plus minus. So when first is odd, then plus sign, even minus sign, odd plus sign, even minus sign. So we require to check that. Now see, enter the number of terms. For example, n equal to 5. So this loop will goes from I equal to 1 to 5, because we require to do for 5 times. So it will go for 5 times. Then we are not taking that simple term 1, 2, 3, 4, 5. We require to multiply that terms by 3. So therefore term is equal to 3 into I. So we just modify this I. Initially I is 1, it becomes 3. Next I is 2, it becomes 6. In this way it will execute. So we take term is equal to 3 into I. I have printed the term also to check whether we are doing the correct operation or not. Now only things is remaining is plus sign or minus sign. So if number is odd, see, if number is odd, plus sign is there, if number is even, negative sign is there. So that's why if I mod to equal to 0 means that number is even number, then at that time what we are doing, sum is equal to sum minus term. Initially we require to keep sum equal to 0, sum equal to sum minus term. But if that number is odd, what we require to do, sum is equal to sum plus term. So in this way we are doing the program. And after end of the loop we are just printing this value sum. Even when you are doing the program at initial, at that time you make a habit of printing the more number of statements, and once it is executing properly, just make the comment so that you will get the track whether you are doing the program correct or not. Even for this program, don't type entire program. First only declare the variables, then you this write down these two statements, just check whether n is proper or not. After that you just write down for loop, just write down term statement, then print term statement, just execute that. And if you are getting 3, 6, 9, 12, 15 means the program is up to this okay. After that you write down this if condition, and in this way you require to do the programming in progressive way. Now the this program is for loop, and this is if you want to do, you can do in a while loop also. Now initially I equal to 1, sum equal to 0. Our condition is while I is less than or equal to n, whatever the value of n you accepted by user, we modified term, then print that term. This is optional, but only we have to check whether it is working properly or not. And if I mod to equal to 0, then minus, otherwise plus, and I plus plus is will take this, because this is while loop. We have to explicitly do increment or decrement. This is very easy program, there is no need to explanation. Now we have to start from 0, so that's why 0, number accepted by user, while I is less than or equal to n, increment, and we just require to print that square, so I into I. If we want to write down this program in while for loop, it's very easy. For I equal to 0, semicolon, I is less than or equal to n, I plus plus. See, and all these printf statements, they are all optional. It's all depend on you how to you want to represent your answer on the screen. Only important thing is to understand this loop, and there is no need to remember even a single program. Sometimes you can remember two to three lines of logic if they are very different, otherwise there is no need. And every statement whatever you are writing, it should be checked by you manually. It require very few minutes to check, and once you make a practice, even by observing you can easily find out the errors or bug in our program. So this is all about the for and while. In the next video also I am continuing this with the for and while exercises on different topics for more expertise. Thank you.